Hello everyone, welcome to my channel. In today's video, I'm going to explain a best-selling book called Hyperspace. This book interprets the theory of multidimensional space in plain language, taking us on an exploration of this mysterious new world. Now, let's follow the footsteps of this book and embark on a wonderful journey through hyperspace. For most people, multidimensional space is likely a very unfamiliar term. In fact, multidimensional space refers to spaces with dimensions higher than the three-dimensional space of our daily lives. For example, there could be four-dimensional, five-dimensional, or even 10-dimensional spaces. Although invisible to the naked eye, these spaces are the key for physicists to unlock the secrets of the universe. Within the scope of human cognition, the theory of multidimensional space is the most likely theory to find the ultimate law of nature. So why did scientists come up with such a seemingly absurd theory of multidimensional space? It turns out that while three-dimensional space is sufficient to explain our daily lives, it is powerless when it comes to finding simple laws that explain the entire universe. Scientists have always believed that the laws of nature should be simple and elegant. And when we express natural laws in the language of multidimensional space, complex equations become exceptionally concise. For example, Einstein's successful theory of relativity unifies three-dimensional space and one-dimensional time into four-dimensional spacetime, simplifying many principles of physics. This demonstrates the tremendous power of multidimensional space to simplify natural laws. Therefore, scientists have reason to believe that by adding more dimensions, we may find that ultimate unified theory, a simple equation capable of explaining all natural phenomena. Thus, the theory of multidimensional space beyond three dimensions was born. When the theory of multidimensional space first emerged in the early 20th century, it was once neglected by the physics community. But in the 1980s, with the advent of string theory, it made a shocking comeback. String theory posits that fundamental particles like electrons and quarks that make up matter aren't zero-dimensional points, but rather one-dimensional strings vibrating. Different vibration modes of the strings give rise to different particles. Even more shockingly, string theory is able to unify the two major incompatible pillars of physics, relativity and quantum mechanics. According to the derivations of string theory, only in a 10-dimensional space can the various laws of physics cohere. So you can think of string theory as a huge jigsaw puzzle. And multidimensional space is the glue that pieces this puzzle together seamlessly. It is the addition of multidimensional space that enables the two seemingly unrelated fragments of relativity and quantum mechanics to miraculously form a coherent whole. Riding on the development of string theory, the theory of multidimensional space has returned to the spotlight of physics, triggering a major revolution in the physics community. Although not perfect, string theory has become the closest existence to the ultimate theory. It can be said that multidimensional space has breathed new life into physics. However, we cannot be blindly optimistic either. After all, multidimensional space still cannot be directly tested at the moment. It is like a castle in the air, beautiful, yet lacking experimental data to sustain it. But physicists say this may only be temporary. Future technological developments may give us the ability to detect the fourth dimension and even higher dimensions. By then, the theory of multidimensional space will hopefully be verified. Moreover, although lacking empirical evidence, the string theory bred in multidimensional space has tremendous explanatory and predictive power. It may provide answers to many ultimate questions that humans currently cannot tackle, such as what triggered the Big Bang. This also reflects the value of the theory of multidimensional space. Therefore, multidimensional space is like a gateway to a new world. We still have some way to go before fully unlocking it, but we have already clearly seen the light of hope. As long as humankind persists in exploration, we will definitely realize the dream of freely traveling through multidimensional space one day. That's all for today. If you are as curious about the mysterious multidimensional space as I am, go ahead and get yourself a copy of Hyperspace. I believe it will definitely lead you to appreciate the infinite charm of multidimensional space. Thank you for watching. See you in the next video.